In this talk, I want to present the study Rhythmic Properties of Sciena umbra calls across space and time in the Mediterranean Sea, conducted by me, Lara Burchardt, and my colleagues Marta Picciulin and Marta Bolgan. Using recordings from passive acoustic monitoring, we analyzed the rhythmic structures of Sciena umbra, the fish, also called the brown meager. We know that Sciena umbra produces rhythmic vocalizations and that the temporal features encode important information, for example, about spawning activity. But we also know that generally fish sounds can be highly influenced by environmental conditions. I'm going to first show you what this rhythmic sounds look like. So we have different sound elements made up of multiple pulsatile sounds, and what we look at is the rhythm between the sound elements. Things that can then influence these rhythms or these sounds in general could be water temperature, as water temperature directly influences the sound production mechanisms. It can be influenced by intra and interspecific competition, by anthropogenic noise, or just the natural ambient sound patterning. To check whether environmental conditions do affect the rhythmic structure of Sciena umbra calls, we ran rhythm analyses on a huge data set across space, time, and environmental conditions. We had recordings from 4 different locations indicated on the map, from Mallorca, Venice, Trieste, and Crete, which are different in several aspects, such as temperature, vessel activity, and others. And the vessel activity you can see in the plot on the bottom, where we have different vessel types and can see that the locations differ quite a lot in composition and overall noise pollution. Like Crete doesn't have any vessel activity. Trieste and Mallorca do have a lot of activity, but only Venice, for example, has fishing and trade boat activity. Even though we have this huge data set across space and time, we find that rhythms are surprisingly stable. If we look at the IOI beat, so the output of the rhythm analyses across the 4 different locations, we find that they are very similar, especially for Mallorca, Trieste, and Crete, and only in Venice we find a significantly faster rhythm, so higher beat frequencies. And if we look across time, this is only from the location in Trieste, we do see that rhythms are also very stable over more than 10 years. Using general additive models, we try to figure out which parameters influence the beat most, and in our data set, the beat was most influenced by the presence of trade and fishing vessels, by acoustic richness, and the progress of the breeding season. And the IOI beat got faster with more trading and fishing vessels, which we only had in Venice, as I showed you before. So that is why Venice also had higher beat frequencies. Gets also faster with higher acoustic richness, so the more different sound types of other fish we find. And it gets faster the later we are in the breeding season. So what can we conclude from this? The consistency we find in rhythms leads us to hypothesize that rhythm is indeed an important fitness-related trait. And the variability in the beat frequency we do find is caused by both biological factors as well as human-related presence. So overall, There is a need for assessment and comparison of vocal rhythms as a critical aspect of fish communication, as well as a critical parameter when evaluating the impact of underwater noise pollution. In this particular example of the brown miga, this is a vulnerable species. Its abundance has declined up to 67% over the last 25 years. So information also about the rhythm, for example, can help in making informed decisions in species management. And with that, I would like to thank you very much for your attention, and I'm happy to take questions on the Discord server.